Students, here is another question on variable mass system called rocket propulsion. It says that, let's read the question. What this question is saying. A rocket with initial mass m is launched by emitting gas with velocity v0 relative to the rocket downward. The mass of the gas emitted per second is k, where k is a constant quantity and obeys the relation k v0 is less than mg. Calculate the velocity of the rocket as a function of time and also find the time when the rocket starts to lift. Okay, so we'll see what are the data are given. We'll calculate those things. So what are things given? First thing is that this gas is coming out at the rate of emitted per second is k. So dm by dt is given as k. And this is coming with a relative velocity of v0. Second thing, another relation is that k v0 is less than mg. What does it mean? We'll check. Okay. And see, we have to calculate the velocity of the rocket as a function of time. And initial mass, its initial mass was m. Okay. So if you see, as the rocket is there, you will draw the free body diagram of the rocket. Then on the rocket there is a force mg will be there. So but m is the initial mass there. So what will happen here? M minus, it is coming the k rate. So m minus kt. I'll erase this one. M minus kt will be there. See, so here the weight is equal to m minus kt into g. And there will be a thrust force will be there on this. And thrust force, we know the dm by dt in the v relative. So dm by dt is equal to k and v relative to v0. So you multiply this will be k v0 is the thrust force. The thrust force acting on this equal to k v0. But as it is k v0 is less than mg, like initial mass itself. So what will happen? Initially the rocket will not be launched, because the thrust that is being applied by the coming out gas on the rocket system is lesser than the gravitational pull of the earth, so it will not be going. So first question is that when it will be rejected? When this k v0 will be equal to this. Why it will be equal to? Because gradually this mass is going down. So after some time this may be equal to, initially it was not. So what will happen? When it will be rejected? M minus kt into g has to be equal to k v0. For the first time it will be starts lifting off. So we have to calculate time. We have to calculate. So m minus kt has to be equal to k v0 by g, or kt is equal to m minus k v0 by g. So t is equal to m by k. Okay, so I will divide. So 1 by k into m by k, or I'll erase this, m by k, and this k goes side, minus v0 by g. At this time, when that time will be this much, at that time only the rocket will start getting lifted up. Now we'll see what else is in the calculate the velocity of the rocket as a function of time. Calculate the velocity of the rocket. So to calculate velocity, we require first acceleration, and to get acceleration we require the net force, and to calculate net force, what do we require? We require the free body diagram, and we have drawn the free body diagram. Based on this free body diagram, will be calculating the we'll be writing the equations of motions of this. Okay, we write the equations of motion for this. Okay, so we'll take this one, copy, and we'll go here, and here we'll paste this one. Okay, so this is our free body diagram. Okay, we'll write the equation of motion for this. So what will happen? First we'll be looking here. So one thing is that m minus kt z, or I will take the upward velocity I will take. Then I'll first take the k v naught. I will take k v naught once after launching of this is more than this, k v naught minus m minus kt into g, that the instantaneous mass has to be equal to m minus, and in addition to this, there are two forces there, m minus kt into acceleration. So if I want to find the acceleration, then acceleration is equal to k by m minus kt into v naught minus g. This is my acceleration as a function of time. This is the acceleration as a function of time I got. From this acceleration as a function of time, I have to integrate to calculate the velocity as a function of time. So for the time being, this is not required. We have used this one. So what we'll do, we'll erase this one. Okay. Let's calculate this one. So what will happen? This, once we got the acceleration as a function of time, this in place of acceleration, what you can write? dv by dt is equal to kv naught by m minus kt minus g, or dv I can take kv naught into 1 by m minus kt into dt minus g dt. What do? You have to integrate both the sides. Okay. What is the limit there? At t is equal to 0, people put the t 0 to t, 0 to v. No. Because at t is equal to 0, this equation was not satisfied. You are not getting launched itself. Okay. No acceleration was there. So what happened? This has started moving. We've seen this has started moving at some time. This much. Suppose let's give this name t dash. So at what time this gets started? They'll give a name t dash. That this value is equal to t dash name given. So at t dash value, only the velocity was 0. Till that time velocity was 0. So I will take this as t dash to t. At t dash, the velocity was 0. And we have to calculate at time t, what will be the velocity. The limit there. So integrating this, we'll get the answer. So left hand side is equal to v after substituting the limit is equal to k v naught into integration of this ln m minus kt divided by minus k. So I have taken the minus k outside. Ln of m minus kt from t dash to t minus z dt integration at t from t dash to t. So if you see this one, this will get the values, will come to this side, the right hand side will go. So let's take this equation to the right hand side. Okay, we'll copy this one, we'll take to the other side of the equations. So okay, this is my equation. So from this equation, what can we write? From this, substitute the limit. So what will happen? This let it be once again here. So this is equal to v is equal to this k cancel and this will go to this side. So what I'll do, minus also I have to absorb this one. So I'll put the upper limit first, then you will put the lower limit later on. So k v naught ln, once we put the limit here, m minus kt dash by m minus kt. This minus I have absorbed here. So up the lower limit first and upper limit later on. Then this is minus g into t minus t dash. This is the velocity. So t dash value is known to us. If we go to there and check what is the value of t dash was there, then t dash we calculated m by k minus v naught by g. M by k minus v naught by g. Suppose I will take this one also right now. So I can take this one. Okay. So I'll copy this one. I will take this side. and I will paste here. Okay, so this t dash value, if I take the substitute, then I'll get the value of v is equal to v naught, and this is equal to ln m minus k t dash. If I multiply it with k and t dash, then this k will be cancelled out, minus v naught k by g. So this is this one there. So m minus, when you get find that the numerator will say m minus k t dash. So m minus k t dash you have to do. Now this m will be cancelled out v naught k by g. So this is equal to ln v naught k by g by m minus k t minus g into t minus t dash. Okay, this is the our equation is there. You want to write little bit simplify this one and want to write, then k is equal to v naught ln k v naught in the numerator, g you take the denominator, m minus kt gone, then minus g into t. I am not substitute t dash till now. T minus t dash is there, so this is equal to t minus t dash. So t minus t dash you will do. So what will happen? This I'll write this one this side, minus g into t minus t dash is equal to m by k minus v naught by g. So when you open the bracket, one g will be cancelled, one gt term will be there, one mg by k term will be there, one mg by k term will be there, and this will be their equation. So this is the equation. So let's this we have substituted. So these two are not required. So I'll take this one. I'll delete these equations. Okay. So this is equal to v is equal to our v naught. V is equal to v naught into ln k v naught into g times m minus kt, and this is equal to, I'll take the this equation is there, v naught by g is there, this is the equation is there. So this anyhow this equation we got, and minus g into t minus m by k minus v naught by g. Let's see what else question has been asked. Let's will go there. So you say that find the time when the rocket start lifted and velocity of the rocket as a function of time. So both we have calculated velocity as a function of time also, and what time it will be get lifted up also. Okay, so this is the value that we calculated. We got the answer. Let's check the answer. What the answer is saying. Yes. So we'll go to and see the answers. So there are two questions were there. So there are two answers there. One is the time at which we'll start launching, 1 by k, m naught minus k v naught by g. Let's check. M by k minus k v naught by g. M naught minus k v naught by g. 1 by k are taken outside. So this is correct. Now see the other one will see. The other one say that velocity as a function of time, v naught ln k v naught by g m minus kt minus g t m by k minus mu naught by g. Let's check what we have got. We've got the same thing, v naught ln k v naught by g m minus kt g t minus m by k. This is also, or the answers that we have calculated is absolutely correct. So we got two answers. This is also correct. This is also correct.